Good afternoon, students. Today I am describing about the projectile motion which are in motion in a plane or vector chapter. So, what is projectile motion? Projectile motion means motion under gravitation. So, for an example, if we throw a stone in air, then from here, if we consider this is the ground state, that means ground of our earth. Now if we throw a stone towards the air, then this stone will move in that direction and reach at a maximum height. After that, it will move like that and reach to the ground at a certain distance, like that. This type of motion, when we throw the stone, if we consider the stone has a mass, so it will first of all, if we apply some force on the stone to throw it, it will reach at the top position. After some time, as on that stone some force, that is called gravitational force, acts to the downward direction. That's why it will reach at after maximum height, it will comes downward direction and reach at the point or at the ground point. But for any projectile motion, that is called the projectile motion, the motion of that stone, motion of any type of thing which we throw under the gravity, that is called projectile motion. That is called projectile motion. Now, for describing or calculating the projectile motion, velocity, acceleration, that all things, first of all must be considered no air resistances are there and no friction and other forces acts on that body which we throw. That means for any projectile motion on that body, no air resistances, no frictional and other forces acts on the moving position. Okay, now let us consider and draw. If we throw, that is the ground point, and from a point, if we throw a projectile towards the upward direction, in that direction, if we throw a projectile towards this direction, it will move, reach at maximum point and comes back again to the ground. Now let us consider here, from here at that plane or the surface of our earth, if we throw this body with velocity u, and angle with the horizontal line is theta, then the component of that velocity towards this x-axis ux equal to u cos theta, which is directed towards the x-axis, and that's why for that component this body will move towards a distance from that point. From that point this body will move towards a distance in that direction, and there will have a upward component of that velocity which is uy. We can say uy equal to u sin theta, as the angle with the horizontal plane is theta, so the component of u on that direction is u cos theta, and in the perpendicular direction is u sin theta. For this kind of velocity, this kind of speed, this body will reach at a maximum height. That means this body will move towards the upward direction for a certain time. Now let us consider this body will move on that direction and reach at maximum height, and at the maximum height this body do not have any kind of velocity or any kind of force towards the upward direction. So we can say here the body have Vx equal to, if we consider there the body have a velocity of v, so Vx equal to, according to the x-axis direction, Vx equal to u cos theta always, but it do not have any force or any acceleration, any velocity towards the upward direction, so we can say Vy equal to 0 here at the upper position. After that it gains some downwards velocity and reach at the ground position. Clear? Now there have some terms like how many times the body will fly on the air from the ground state to ground state. This is called time of flight. The time on which the body will fly, this is called time of flight, and we express it as capital T. Similarly, maximum height whatever reach that body is called maximum height and expressed at capital H. So we can write maximum height for the body equal to capital H, and the whatever distance in x-axis it moved, that is called range of the body. Range or horizontal range of the body, and that is written as capital R. Now if we look that motion of that body, we look that on the x-axis the body will do not change any speed. At first it have a speed of u cos theta or velocity of u cos theta towards this horizontal line, so it do not change its speed at any instant of time, because there do not have any kind of force acts on that body towards this x direction. So as there is no force acts towards the x direction, so there is, we already know that force equal to mass into acceleration. So as there is no force, so there is no acceleration, so velocity does not change towards the direction of the x-axis or horizontal line. But if we consider the motion under the x-axis, motion of x-axis, if we consider, so we can say ux, that means velocity of that body is equal to u cos theta, and acceleration on that direction is 0 because there have no force. So x direction velocity for that body is constant. Clear? Okay. And if we consider about the y-axis motion, that means upward motion, so at first they have an velocity y equal to u sin theta, and there have an force for every time on that body towards the downward direction, that is called gravitational force. So as they have an gravitational force, so they have an gravitational acceleration small g also. So this gravitational acceleration acts always towards the downward, and this velocity moves to the upward, so we can say that acceleration towards y-axis equal to negative of g, because it is directed downward direction. It try, this gravitational force, this gravitational acceleration try to move this body towards the downward to the ground position, and try to move this body towards the ground position and reduces the velocity. So there have a negative acceleration, and that's why we say the negative acceleration ay is minus g. Velocity is in the y direction, and first it will decrease till maximum height. So velocity first, if we give some velocity u sin theta on the first time, it will decrease till the maximum height, and after reaching maximum height the velocity according to y-axis is 0. After that it will increase its velocity towards the downward direction. So we can say that velocity in y direction or y-axis first decreases till reach at maximum height. After reaching maximum height, at maximum height, the velocity along the y-axis is 0, and after that it will increase towards or to downward direction. So velocity increases after reaching maximum height. When it falls, the velocity increases towards the downward direction. So we can calculate the time of flight. Now let us consider this point. Maximum height point is B and the reaching point of this ground is C. Now for A to B, we can say, if we consider about the motion from A to B, we can say that for that case, in that x-axis direction the velocity is u cos theta, which is constant, and y-axis direction velocity is u sin theta, which is changeable because variable, because it decreases with respect to time. Clear? So if we take t time takes to reach at the maximum height, if we consider it takes t time to reach at the maximum height, then from A to B motion we can calculate uy equal to u sin theta according to y-axis, and ay acceleration equal to minus g, and vy at reaching at maximum height is velocity is 0. So if it will take t time to reach maximum height, so we can say that using the formula of motion or laws of motion, we can say that v equal to u plus at. So we can say what is the final velocity? 0. What is the initial velocity? U sin theta. And what is the acceleration? Minus g into time taken by it is t. So from that we get that minus gt. We can say u sin theta minus gt equal to 0, or we can say gt equal to u sin theta, or we can say t equal to u sin theta by g. That is the time required to reach at the maximum height. And similarly, when this body reach from maximum height towards this ground state, it will take same time, t time, that is u sin theta by g. So total time taken by this body for this flying in the air is t plus t, that is 2t. Here t plus t is 2t. So we can say time of flight for projectile motion t equal to 2u sin theta by g, or 2 into small t. That is called time of flight. Clear? So we can calculate the time of flight, whatever time it required to reach that maximum height or flying over the air. We also calculate the maximum height using this formula. If we consider the maximum height is h, so for y-axis motion, that is the maximum height h, and the velocity is u sin theta, final velocity is g 0, and the acceleration, that is negative g minus g. So using y-axis directional motion, using the formula v square equal to u square plus 2as, we can say that the final velocity is 0 square, initial velocity u sin theta whole square plus 2 into acceleration minus g, and maximum height is h. So from that we can say 2g into capital H equal to u square sin square theta, and we can say h equal to u square sin square theta divided by 2g. That is the maximum height reached for any projectile motion. So we can calculate time of flight. Similarly, we can calculate the maximum height. Now if we consider the x-axis motion, like that. If we consider the x-axis motion, ux is the velocity and time taken to reach at point C is 2 small t, already known, that is called time of flight. So we know that we can calculate the range of that body, and range is equal to total distance covered by that body equal to velocity of that body along the x-axis direction. Velocity of that body along x-axis direction is u cos theta into time taken is 2t. So we can write u cos theta into 2 into small t, that means time of flight capital T. Also we can write u cos theta into capital T. So we can write u cos theta into capital T is 2u sin theta by g. So when we calculate this, we can write 2u square into 2 sin theta into cos theta divided by g, and we already know that 2 sin theta cos theta equal to sin 2 theta. So we can write u square into sin 2 theta divided by g. Sin 2 theta divided by g is the range of that body. So we can write here range of that body equal to u square sin 2 theta divided by g is the range of any projectile motion. So we can calculate the time of flight. Similarly, we can calculate the range, and also we can calculate the maximum height reached for any projectile motion. Thank you.